Now we're going to look at solving linear equations. And as we move on here, we'll see where the idea of linear equations come from in words. Um, but we're going to look at the idea. So I'm going to start with an example. And we'll have 7 times the quantity plus 12 equals 3 times the same quantity minus 4. Now, the thing we're going to note in linear equations is that they will have one variable, and the power to the variable will be 1. It won't be an x squared or an x cubed. And in linear equations, it's the examples we have been doing before. We have tried to use linear ones in our examples so we could kind of just take apart what we've been doing in the previous material. And so we want to get the variables on one side and the constants on another. It doesn't matter if the variable ends up on the left-hand side or the right-hand side. People have a tendency to push the variable to the left-hand side because then when you're done, you'll have the variable equals some number. And we like to read it that way. But what I do is I try to find what's the easiest mathematics. I don't like dividing by negative numbers, so I generally tend to start by finding where the largest values of x's are. So I have 7 of them here. So I'm going to want to bring everything over to the large value. So I start by what I do to one side, I do to the other. And in this case, I have to get rid of this. So I get rid of it by subtracting. And whatever I did to the one side, I do to the other. And this is one of the things in this. I should give myself a little more room, since I know I'm going to do a subtraction here. I want to get rid of this from this side, so I subtract it. And because this is something I did to this side, I also have to do it to that side. Now, because I chose this to undo or remove the variable from this side, it does what I wanted. That variable goes away, and I'm left with negative 4 on the right-hand side. On the left-hand side, I have to subtract 4x from, or 3x from 7x to get 4x. And now I have to get rid of this 12. So I want to undo the addition. So I subtract that, but whatever I do to one side, I do to the other. Oops, minus 12. And so I have 4x equals negative 16. And now to completely liberate x, I'll divide both sides by 4. And I have a statement of what my variable was. And so I can come back up here and check. And so 7 times negative 4 is negative 28. 3 times negative 4 is negative 12. And so I get negative 16 and negative 16. We're good on that. And let's do another linear equation. And hopefully through these examples we'll get a pattern of how whatever we do to one side we do to the other, and we look to get the variable in one place. There will be different ways that you will do that, and practicing the homework sets on these really helps. So let's see. 5y plus 5 equals negative 2y minus 10 minus 4y. All right, I'm going to simplify both of these expressions before I move anything across the sides. So 40 plus 5 is 45, and I still have a minus 5y here. So I simplified the left-hand side. Negative 2y and negative 4y is negative 6y. All right, again, I want to go to the bigger value of y, which happens negative 5 is bigger than negative 6. So I'm going to be moving my y's this way. So I'll give myself some space. This is a negative 6y, so to get rid of it, I have to add 6y. And whatever I do to one side, I do to the other. Now, because I chose to do the opposite of this, they go away, right? It's like I covered this with my hand. And on this side, I now simplify. I get 45 minus 5y and plus 6y is plus y. And now I need to get rid of the negative 45. Or not the negative 45. I need to get rid of the 45 by subtracting 45. And whatever I do to one side, I do to the other. Getting ahead of myself here. There we go. And that's negative 55. And these two things, because we chose that to make it go away, gives us this. And now I'll come back and check. Here's my left-hand side. I'm going to write my right-hand side down here. So we can break up an equation on two lines sometimes, especially if it gets a little long. If you usually put the equal sign at the very end so that we know that's happening of a line. And since I'm running a bit out of room here, that was 55. I'm going to write it like this. So here I'm doing my check. All right. No y. That was 5 times that. Sorry. Let me make sure I wrote this right. 40 minus 5y. So there's 5y. Plus 5. Good. Got my left-hand side. Equals negative 2y minus 10 minus 4y. I think I'm scared of this multiplication. So 5 times 5 is 5. Or 25. Carry my 2. 5 times 5 is 25. I have the carried 2. So 275. And a minus would give me a plus. So my left-hand side is that. Let's come over and do my right-hand side. So minus 2 times negative 55 is 110. And a minus times a minus, it's positive. So minus 10. And then I'm going to 4 times 55 is 0. Carry my 2. And a minus times a minus is positive. So let's add these up. Did I get everything in there right? Yeah. So 40, well, 5 plus 275 is 280. 280 plus 40 is 320. And let's see here. 110 minus 10 is 100, and 220 plus 100 is 320. Whew. Probably should have used some scratch paper off to the side on that, but we checked. Right? Notice how sometimes the checking can be really odd because the numbers get big. All right, let's look at the distribution property in these. But we've got our game here. Our game is isolate the variable and like onions. So if we have a distribution coming in here, all right, so I'm going to distribute the 6 to both terms first. So I get 6a minus 30 equals 4a plus 4. I'm going to bring this over, so I'm going to subtract 4a from both sides. And I'm doing that because that will make these cancel out, and that leaves me with just a 4 on the right-hand side. Then I'm going to simplify over here. 6a minus 4a is 2a. And now I'm going to add 30 to both sides so that this goes away. Right? And because I chose the opposite, it goes away. And now I'm going to divide by 2. And whatever I do to one side, I do to the other. So I get A equals 17. Now I'm going to check. So 6, 17 minus 4 equals 4 times 17 plus 4. So 17 minus 4 is 13 times 6 equals, and let's do this, 8, carry my 2, 68 plus 4. And 68 plus 4 is 72. 72. Oh, it's minus 5. See, you have to make sure you copy the thing over correctly. So 17 minus 5 is 12. Sorry about that. I'm having a little bit of copy issue today. I think I need more coffee so I can copy things well. But there we go. And we check. And so our steps here really are, distribute if necessary, right? If there are any parentheses, distribute. Simplify the left-hand side and right-hand side. And then I'm going to say we gather the variables and constants together. And we do this by using all of our rules until, and then isolate the variable. That's isolate the variable. And then check your answer. And so we do the distributions like we did here. Then we simplify the left-hand side and the right-hand side. So when there's two like terms here, we would bring them together, and then get the variables to one side and the constants to another. And then if there's a coefficient in front of the variable, we divide by it. And that will get us an answer for linear equations. Linear equations don't have many more steps than that. So we work our way through and solve. Now, one of the things we'll see in word problems is that we have an idea for addition, subtraction, multiplication, and division, what words to use. But there's a one for the equal sign. And the equal sign will appear in language. We'll actually say one thing equals another. We'll say gives. The summation of so much gives the result. We'll use gives in that. Is and was does the same thing as equal. Yields, amounts to, is equal to, produces. All of these help generate what are clues to an equal sign. So, for example, the product of 7 and 6 is 42. This reads the product of, tells me I'm going to multiply these two things, and is equal. So this translates into a mathematical statement of 7 times 6 equals 42. And it's a true one. Let's see, twice the sum of 3 and 5 is equal to 16. All right, so twice the sum of. So I'm multiplying the sum of something. So 3 plus 5 is part of the sum. And I have to multiply it by 2, so it gets parentheses, because this thing here is talked as a unit, and then multiplied. I'll write it as a unit. And then is equal to, and that's true. All right, this is chapter 3, section 3, and I'm going to look at writing sentences as equations in 3-4. And what we'll do is, I'll probably use some slides for this so you don't see my handwriting on all of these equations that come out. Okay? I will talk to you on the other side.